Okay, so in the last video, you were factoring, you were solving by factoring. We were kind of here, and I'm just going to keep picking up with that because I'm in a roll, and you did this for your Now You Try, so I'm going to skip over it, and I'm going to pick it up from there. So what we're trying to do is, again, solve quadratic equations by factoring. So let's just go through a couple more examples. You should have them. And we're going to go ahead and change the name of this video, so let's just kind of make sure we're all clear on this. We're going to pick up from where we were, and this would end up being, it's called polynomial equations and factoring. That's this unit. We would take some time, obviously, and it's going to be 4b. So polynomial equations and factoring 4b, this video will be called. And your notes might just say 4a on it, but be aware that it's a two-video type of thing. That video that you watched for A was one homework assignment, so you don't need to go through this one, just so you're aware. So here we are. We're looking at number 2, and we're going to try to go through the steps. So I'm going to read the steps that you're looking at on that page. You see how it says set the right side equal to 0? We're going to do that. So it's already done. Step 1 is already done. The next question is, can we do steps 2, 3, and 4? So step 2 is to factor the left side, and I look at this and I say, hey, is there a GCF? Okay, we spend a lot of time factoring, so I'm hoping that factoring the left side is just, boom, you can do it. It's pretty instant. That's what it needs to be. So we take a 2 out, and we say, okay, well, hey, 2 times x squared is 2x squared, 2 times negative 6x, 2 times positive 9. So that's factoring the left side, and we'll call that good at this point. All right? We have to assume that factoring is a pretty solid thing. It's a big topic. We can't keep reviewing it. You've got to go back and make sure you're strong on it if you aren't at this point. Now what we're going to do is we're going to actually, oh, we're not even done factoring. My apologies. We've got to put a second check here because we got more work to do. This is a 2-step factoring. We need to break it down into x minus 3, x minus 3. And now we factor the left side. Now we need to set each factor equal to 0. So what I'm going to do is I'm going to take the factors, which is this and this, and I'm going to set them equal to 0. X minus 3 equals 0. X minus 3 equals 0. So now I've set each factor equal to 0. And my last thing is to solve the equations from step 3, the green equations. And I think I'm pretty good about sticking to this color flow. I usually do the same color flow. So my last step is purple, if I remember correctly. And that is to just solve these equations. So add 3 to both sides, x equals 3. You'll notice that when you solve this equation, x is equal to 3 again. So there's not really a whole lot to that. If x is equal to 3 both times, then you just need to write x equals 3. That's your answer. So you're in pretty good shape after that. So that's that problem. Let's kind of go on to the next one. And if you want to, you can pause the video here and try this problem. If not, just keep on watching, keep playing. All right, so my hope is that you pause the video. I don't know if I gave you enough time to do that, but I got to keep moving. So we're going to work through this problem. Is the right side set to 0? Ask yourself that question. And the question, I guess the answer is no. The answer is yes, the right side is 0. So that's done. So now we got to factor the left side. So factoring the left side means we always ask ourselves this question. Is there a GCF? You need to ask that question every single time. That's the first question that crosses your mind when you do a factoring expression or a factoring equation. Whenever you're factoring, is there a GCF? They both have x's. So hopefully you know that the GCF is x. And this is what it factors to. It breaks down like that. We're breaking down the left side. We're not paying attention to the right side. And we're now going to set each factor equal to 0. That's the next step. That's the next thing we need to do on the list. So I'm going to set each factor. This is actually a factor, by the way. So x equals 0, and x plus 6 equals 0. Okay, so now we have those. And step 4 is to solve each of those equations. Now, I know a lot of you at this point in your lives are like, why is he doing this step 3 and step 4? Like, why is he making us solve these equations when we could just switch the signs, right? Some of you just kind of are on to that. The problem is that it's not going to work forever. It's not always going to work by switching the signs. So you need to set them equal to 0 and solve them, because in the not-so-distant future, this trick of just switching the positive 6 to a negative 6 won't work. It will work for the time being. Actually, in here, though, you also see this x, and you're setting the x equal to 0, and there's nothing to solve. So I guess your trick wouldn't work there either. You got to watch out for that. So those are those problems. I want you to take some time doing the now you tries here. You might notice that some of these are not set equal to 0. You also want to notice here, I'm going to just give a hint on the last two here. This one, watch out, because when you do set it equal to 0, it's a different type of factoring, one that I think you'll be okay on, but you just got to be aware that it's something that adds to 0 and multiplies to negative 25. I think you'll be okay on 1 and 2, probably. Just set them equal to 0. And the last now you try, so there's 4 now you tries. The last now you try, make sure you put it in standard form, like the m squared and then the m and then the constant at the end. So you got to have the highest power, then the power of 1, and then the constant at the end. So make sure it's in the proper order. Okay? So that's where we are for that. We're in pretty good shape here. I just want to see where we're checking in as far as the video is going. Okay, so because I split this one worksheet into 2 papers, I'm going to go on and do a couple more examples here. And I do expect you to do them in the margin. Okay? So I'm just going to do a couple of these examples, nothing crazy, and I'm going to have you do them in the margin. So I'm going to look at this problem here. All right? And I'm going to look at this problem here. I like both of those. So when we're looking at this problem 34, step 1 is to set it equal to 0. So clearly we have to subtract 24 on both sides. Okay? We cannot combine a negative 5n with a negative 24. They're not similar terms, of course. So this is not going to work out. We're going to have to have n squared minus 5n minus 24 equals 0. The next step was to factor the left side. So we're going to break that into 2 things that multiply to negative 24 but add to negative 5. So I think that's going to be negative 8 and positive 3. And then we are told to set each factor equal to 0 and solve. So I will take this, x minus 8 equals 0, so x equals 8. And I will take this, x plus 3 equals 0, so x equals negative 3. And those are my 2 answers. And what's cool about that is you can plug them back into the black equation right here. You can plug them back into this equation. I want to make that very clear that you can do that. You can plug them back into this equation that I'm cleaning up here, and it will equal 24 if you plug either of those in. Now, when you plug the x equals 8 in, you got to plug it in for both n's. It's actually an n, sorry, not x. And when you plug in that n equals negative 3, which says x equals negative 3, you will plug it in for both of them when you're doing that, not one or the other. And you don't plug one into one and one into the other. You got to plug, each time you have to check it twice by plugging in the variable for both each time. Okay, and the last one, I think, this video is going to be on the semi-short side, which is kind of nice. I'm going to work through one more example. It's right here. And what we're doing on that one is, let me just see if I can remember my colors here. I have a color-coded, okay, blue, red, green, purple. So on this one, right here, we want to first start by setting equal to 0. So we're going to subtract 15m from both sides. Okay, so that's m squared minus 15m plus 10 equals negative 34. Now we have to add the 34 to both sides. As we're doing that, we're getting the following: m squared minus 15m plus 44. Okay. So that's important. We have a little bit going on with that. Hopefully that whole first blue step is no big deal. You're understanding that you have to have the terms in the proper order. I hope you know what that means. And you have to set equal to 0 completely. So sometimes there's a different way of doing that. Sometimes you have to combine some more terms. Now the next thing we need to do is we need to factor the left side. So 44 is 11 times 1, and we're trusting that you're pretty good with these things. Oh, sorry, 11 times 4, my mistake. So that's going to be negative 11 and negative 4, and that all is going to come out to 0. So we've now factored the left side, and step 3 says to set each factor equal to 0. So m minus 11 must equal 0, or m minus 4 must equal 0. Why is that? Because if this right here, if this green squiggle is equal to 0, you have 0 times something. And 0 times anything is going to equal 0. So if m actually winds up equaling 11, if m equals 11, which is our last step, then the whole equation is going to equal 0 here. This whole thing is going to equal 0. And if m is equal to 4, that's also going to make that happen. If m is equal to 4, that's also going to happen. So I'm going to do one more thing. I'm going to check the equation, making sure that I have enough time here. I'm going to check the equation, just take another minute or two. First, I'll check m equals 11. So 11 times 11 is 121. Hopefully you see what I'm doing. I'm taking 11 and squaring it. Okay, this guy right here, bringing it up. So that's 121 plus 10 is equal to 15 times 11, this guy. So I guess that's 150, 161, I think. 161 minus 34. So 121 and 10 is 131. And 161, I don't like that. And 161 minus 34, 150. I see what I've done wrong. This isn't 161. This is not 161. It's actually 165. So I caught that mistake, luckily. So 165 minus 34 is 131. And now we've seen that it works out. Now, in the interest of time, I'll save you a little bit of time. I only checked one of them. I could have checked this one. I could have checked this one. I want to stress that. And if I had plugged it in for both m's on both sides, it would have worked out. It would have equaled. It would have been different. It wouldn't have been 131 equals 131, but it would have worked. So we could check either of those as solutions. Okay, we'll keep the video here. It's about 12 or so minutes, and we'll just cut it. I hope that went well for you. Maybe it's helpful if you didn't do well on the Now You Tries. You can swing back now that you've seen a couple extra examples. But hopefully it was helpful, and I will see you guys soon.